Welcome back. Okay, so yesterday or in previous session we have seen that how to given signal can be converted into a operations. Means suppose let's say a given signal is there, we have to perform some time operations and we have to convert the into another signal. That's what we have seen. So in that we have seen one example also. So let's see one more question based on that previous GATE question, electrical 2010, so that you can understand how to solve that question. Okay. In your workbook, it's a question number 8. It is given like this. F of t and they have given g of t, which is like this. And they said if g of t is equal to f of alpha t minus beta, then find alpha and beta. What is alpha, beta values? Options are given like this: 1 by 2, option B 1 by 2, 3 by 2, option C 1 by 2, 3, option D 2, 3. Okay. So it is given like that. Then we have to see what are the alpha and beta values. Okay, can you try this? First of all, we don't have any amplitude scaling factor because both the amplitudes are 1 only. Next, do we have the scaling factor, time scaling factor? I told you to find out the time scaling factor, what is the formula we have to use? That is available width by required width. So available width, how much is the available width here? That is nothing but 1. What is the required width here? 2. 3 to 5, that means 2. So available width divided by required width. So available width is 1 by 2. So that is what the alpha. Once we got the time scaling factor, just apply the time scaling factor so that you can see what it is going to be. Let's say f of t by 2. How we can draw this? That means we have to expand it by 2. So this is exist 0 to 2. That's what the f of t by 2. What we have to do this waveform with this waveform so that we can get g of t. So you tell me. So forget about the function. By seeing the graph, what we have to do with the graph so that we can get the g of t. So I have to shift this graph by 3 units so that I can get g of t. Shifting right side by 3 units, that means t has to be replaced with t minus 3. That's what it means. So finally, to get g of t, I can say g of t is equal to f of 1 by 2. T has to be replaced with t minus 3. T has to be replaced with t minus 3. That means this waveform has to be shifted right side by 3 units. That means t has to be replaced with t minus 3. Finally, I can get f of 1 by 2 t minus 3 by 2. So finally we got the expression g of t in terms of f of t. Alpha is equal to 1 by 2. Beta is equal to 3 by 2. So option B is correct. Okay. Please time operations on a continuous time signal. Now let's perform the same kind of operations on the discrete time signal so that we can understand what are the things we have to take care of and what are the things we have to be careful. Okay. Let's see. If I take example I am giving you directly. X of n is given like this. 2, 3, 4, 5, 6, 7. Let's say arrow is here. Okay. Simply if I ask find x of n minus 3, x of n plus 2, x of minus n. These things I have to find. Okay. Listen carefully. First try to understand what exactly we are doing so that I will give you the notes how to find out these things in a very simpler manner. Let's see. What is this arrow indicates? Arrow indicates n is equal to 0 position. Let's call it as a y-axis. Let's call it as a y-axis. We know delay means the signal or sequence has to move in the right side. Suppose if it is a advance means the sequence has to move in the leftwards. Understood? Or suppose if it is a time reversal, we have to fold it. Okay. Listen here. X of n minus 3. That means the sequence has to move in the right side by 3 units. Let's say arrow has to be fixed because it is a y-axis, so I am fixing this arrow. If it is 1 unit moving in this direction, right side by 1 unit, then 3 comes here. That means the arrow comes at 3. 2 units means 2. Next 3 units means there is nothing, so we have to assume it is a 0. So finally, this is what we are going to get. 0, 2, 3, 4, 5, 6, 7. So here is the arrow. Next, x of n plus 2. That means sequence has to move in the left side by 2 units. That means, let's say, if it is moving 2 units, if it is moving 1 unit in this direction, 5 comes here. If it is moving 2 units in this direction, 6 comes here. So arrow position is at 6. 2, 3, 4, 5, 6, 7. Arrow is at 6. Next. To find x of minus n, that means we have to fold the sequence. Let's say keep the 0th position. If I fold it. So if I fold it 7, 6, 5, 4. Next if I fold it 3, 2. So 7, 6, 5, 4, 3. This is what we are going to get. Okay. Now please try to understand what I am saying. We know that x of n minus 3, that means delay means signal or sequence has to move in the right side direction by 3 units. Next, but virtually if you observe carefully, this arrow is moving in the leftwards. I hope you understood what I am trying to say. So we can say to find x of n minus 3, sequence has to move in the right side by 3 units. Or in another way, we can say arrow is moving in this direction. That means in the leftwards by 3 units. As simple as that. Next. To find x of n plus 2, sequence or signal has to move in the leftwards by 2 units. Or arrow is moving in the rightwards by 2 units. So that's the way. Next, to find x of minus n, what we are doing is simply keep the 0th position as it is and write the sequence in the reverse order. So write the sequence in the reverse order 7, 6, 5, 4, 3, 2 and keep the 0th position where it is 4. So that's what we have to say. Clear? So let's try to write these points. First take down, then we will write those points what I have discussed here. Let me write those points. In discrete time case, first point, if the signal or sequence is delayed, if the signal is delayed, then the waveform or sequence, the sequence shifted towards right or arrow is shifted towards left. Towards left. That's the one point. Second point. If the signal is advanced, the sequence shifted towards left or arrow is shifted towards right. Okay. Next, third point. In time reversal, keep the 0th position as it is. And write the sequence in reverse order. Reverse order. That's what we have to do. So remember these 3 points regarding delay, advance and time reversal. Okay, take it. Fourth question. Suppose if I try to find out x of minus n plus 1. I told you to perform these kind of operations, we can go in a natural method or unnatural method. Natural method means in this direction we have to move. If in this direction if I perform the operations, first we have to perform the shifting operation, then time reversal. But let's see, we already got x of minus n. That means first I want to perform the time reversal, then shifting. That means I have to go in the unnatural method. Suppose if I want to go in the unnatural method, I told you first we have to rewrite this expression like this. X of, if I take minus common, n minus 1. So already we got minus n. Then what is the operation we have to do? So it is looking like plus here. After taking minus common, it is looking like minus. So we have to perform the delay operation. So if I delay by 1 unit, then this will comes at 5. Understood? So delay means arrow is moving in the left side direction. So I can say 7, 6, 5, 4, 3, 2. Arrow is at 5. Otherwise, you can go with x of n plus 1, then minus. So still you are going to get the same thing. Okay. Okay. Next, suppose let's say if I ask, very important, can you find out x of n minus 1 by 2? X of n minus 1 by 2. That means we have to delay the sequence by half unit. So just remember this, it's not possible. So this kind of shifting is not possible because we can do the shifting only with integers. We cannot do the shifting with non-integers. That means in the discrete time case, non-integer shifting is not possible. So try to avoid this kind of shifting. So non-integer shifting. Is not possible in discrete time signals. In discrete time signals, non-integer shifting is not possible. So you cannot do it because let's say, suppose if it is shifted half unit, that means 1 will go to 1.5. So I told you it is defined only at integers. It is not defined at a non-integers. So I can simply say at those values we don't know. So I can simply say non-integer shifting is not possible. Okay. Next, discrete time scaling operation. Discrete time scaling operation. Let's see this one, which is very important. Here we can say x of n is given. From that we can find out x of kn or x of n by k, where k is nothing but integer. So if you could find out this kind of thing, so usually suppose in a continuous time case, we can call it is a compression, we can call it is a expansion, but these are the names which are not used in the discrete time case. So we don't usually use compression and expansion in the discrete time case. Then what are the names we are using? So here we are using decimation. This is also called as downsampling. This is called as interpolation. Or upsampling. Upsampling. So this is what the decimation or downsampling or upsampling. Okay. So try to understand. First take this, then we will see one example how we can solve this kind of things. What do you mean by upsampling? What do you mean by decimation? Okay. Let's say one signal is given, example I will take so that you can understand easily. X of n is equal to, let's say 2, 3, 4, 5, 6, 7. Here is the arrow. Can you tell me what is the x of n? So this arrow indicates 0 position, -1, -2, 1, 2, 3. So let's see. X of -2, 2. X of -1, 3. X of 0, 4. X of 1, 5. X of 2, 6. X of 3, 7. So these are the samples what we know. Okay, x of n samples. Suppose somebody is asking, you have to find out a new signal y of n, which is nothing but x of 2n. You have to find out a new signal y of n, which is nothing but x of 2n. Let's see one by one. If I take y of -2, is it a possibility? If I take n value -2, then x of -4, which is not there. So I can start from -1 only, y of -1, which is x of -2. How much it is? 2. Next, y of 0, that is the next sample we are having. That is going to give you x of 0. How much it is already given? 4. Next, y of 1, which is x of 2. How much? 6. Next, if I go with a y of 2, that is going to be x of 4, which is not there. So these are the samples what we got. So if I write them, this is nothing but 2, 4, 6. So this is what the final thing what we are going to get, x of 2n. If you observe carefully, x of n and x of 2n, we are having so many samples in the x of n, whereas in the x of 2n, we are having only some of the samples, not all the samples. This is called as downsampling. We are getting less samples, is called as downsampling. So that means, let's say, sir, is it required to do these kind of things every time to find out x of 2n? No need. So let's see how we can do this. To do the decimation x of 2n, keep the 0th position as it is. Keep the 0th position as it is. And pick every second sample in the right side and left side direction. Pick every second sample means 1, 2. Next, 1, no, nothing is there. Next, in the left side direction, 1, 2, yes. So 2, 4, 6. This is what x of 2n. Suppose if somebody want to find out x of 3n, then what we have to do? Keep the 0th sample as it is and pick every third sample towards right and left. Then what we are going to get? 0th sample as it is, third sample, 1, 2, 3. Next, in this direction we don't have anything. So what we are going to get? 4, 7. I hope you understood how to find out the decimation of a signal. So I am just writing observation to find x of kn. To find x of kn, come on. Keep the 0th sample as it is. Keep the 0th sample as it is. And pick every kth sample. Every kth sample towards right and left. This is how we do the decimation. Okay, take this notes. Or we can call it as upsampling. So again I will take the same example, x of n. Let's say I have to find out a new signal y of n, which is x of n by 2. X of n by 2. Let's see one by one. To get x of minus 2, what has to be n value? Y of minus 4. So this is x of minus 2. How much? 2. Next sample in the y, which is minus 3. Then x of minus 3 by 2. So we don't know this value, just keep it. Okay. Next, y of minus 2, that is x of minus 1, which is 3. Y of minus 1, x of minus 1 by 2, which is also don't know. Next, y of 0, x of 0, how much? 4. Y of 1, x of 1 by 2, that is also we don't know. Y of 2, x of 1, that's what it is, 5. Y of 3, x of 3 by 2. So let's say this value is unknown. Again, y of 4, x of 2, that is 6. Then y of 5, again it is x of 5 by 2, unknown, we don't know that. Next, last sample value, I don't have space. Let's say y of 6, x of 3, which is 7. Okay. Now let's see. These are the values we don't know actually, because the signal is not defined for non-integer values, so we don't know that values. So I cannot say that value is 0, but I can simply say we don't know that value. But in our syllabus, we are having interpolation technique called as zero interpolation. What do you mean by zero interpolation is, whenever you see a unknown value, you can assume or interpret or interpolate as 0. You can assume it as a 0. Then we can say this value is equal to 0. This value is equal to 0. This value is equal to 0. 0. 0. So if I write this sequence, how it look like? 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7. Here is the arrow. Arrow position is not going to change. So, sir, do we have to do this kind of thing in interpolation? No. Simply try to understand. If you try to find out x of n by 2, that means here we are having integer 2. 2 minus 1, that is nothing but 1. 2 minus 1, that is nothing but 1. So we have to insert 1 0 between each sample. Between the samples, we have to insert 1 0. In simple words, suppose let's say, if I try to find out y of n, which is nothing but let's say x of n by 3, that means we have to insert 2 zeros after each sample. 2 0 0, 3 0 0, 4 0 0, 5 0 0, 6 0 0, 7. So that is what the sequence what we got. So in simple words, what we have to do? Observation. To find x of n by k, insert k minus 1 zeros between the samples. That's what we can do. To find x of n by k, insert k minus 1 zeros between the samples. That is as simple as that. Okay, take it. Here, one very important observation we have to make. What is that observation? Try to see. Suppose, let's consider a continuous time case. In a continuous time case, let's say, suppose if I, let's say, expanded by 2, compressed by 2. Okay, let's see if for this kind of system the first block will do expansion of the signal, the second block will do compression of the signal by factor 2, by factor 2. If a signal x of t is given, because I am considering continuous time signal, if it is expanded by 2, then what we are going to get? X of t by 2. Again it is compressed by 2. If it is compressed by 2, t has to be replaced with 2t. Then x of 2t by 2, which is nothing but x of t. Which is nothing but x of t. No doubt. So that means if you first expand the given continuous time signal and compress the signal by the same factor, you are going to get the same signal. You are not going to get any difference. So you are going to get the same signal. So you are not going to lose anything here. Next, in the similar manner, what if I do first expansion? What if I do compression next? First expansion, then compression. What I am going to get? Same continuous time signal. If x of t is given, sorry, I have written the same thing again. First compress, then expand. Let's see. If it is compressed, t is replaced with 2t, x of 2t. Expanded means t has to be replaced with t by 2. Then x of 2 into t by 2. Again 2 get cancelled. Finally x of t. So the conclusion what I am making here, in a continuous time case, if you expand the signal then compress the signal by the same amount, it won't make any difference. You are going to get the same signal again. So if you compress first then expand, still you are going to get the same kind of thing. But what about the discrete time case? So this is what very important. So let's come into discrete time case. First, let's say interpolate by 2. Next, decimate by 2. So to understand this, I am not taking just x of n, just take one example so that it is going to be more simpler. Let's take x of n, which is 1, 2, 3. Here is the arrow. If I take interpolate by 2, that means we have to insert 1 0 between the samples. So what we are going to get here? 1 0 2 0 3. That is what the output of the first block. Next, decimate by 2. What do you mean by decimate by 2? Keep the 0th sample as it is and pick every second sample. Then I can get 1, 2, 3 again. So is it nothing but x of n? Yes, absolutely it is equal to x of n. That means in the discrete time case, if you do first interpolation then decimation by the same amount, it won't make any difference. You are going to get the same signal x of n. But let's say, what if I take first decimation? Next, interpolate. Let's take the same example. X of n is equal to 1, 2, 3. Decimate by 2. That means keep the 0th sample as it is and pick every second sample. So we are going to get 1, 3. Interpolate by 2 means we have to insert 1, 0 between the samples. So I can get 1, 0, 3. Is it x of n? No, it is not equal to x of n. It is not equal to x of n. So if you observe carefully, if you do the first decimation, then interpolation, we may not get x of n. That is not a possibility. You may not get x of n. Why, sir? Because in the decimation, we always lose the information. We always lose the information. And that last information in the interpolation technique, we can assume it as a 0. So that's the difference. So I can say first decimation, then interpolation, that may not be x of n. So be careful with. So interpolation then decimation, it won't make any difference. Whereas decimation then interpolation, yes, definitely that may not give you x of n. So be careful with this one. Okay, please make the notes.